Okay, let's continue with the second part of the section. Now we will be talking about solving questions about the relation between slope of the function and concavity. So if slope of the function is increasing, then function is concave. If slope of the function is decreasing, then the function is convex. In other words, we can say if first derivative is increasing, then original function is concave. First derivative is decreasing, then original function is convex. So we are going to solve questions about these relations. Let's take a look at these examples. On this graph, we see a concave graph. The function is concave. The slope is increasing because wherever you put the tangent line, from left to right, as the graph rising from left to right, we see that the slope is increasing. It is negative at first, and then zero, and then positive, more positive. So from left to right, slope is increasing, meaning f prime is increasing. And since the graph is opening up concave, then the sign of the second derivative is positive. Similarly, if we have a convex graph from left to right, the slope at every point, slope of the tangent line at every point will decrease from left to right. It is positive at first, and then zero, it becomes negative, more negative, less negative, sorry. So it means slope is decreasing, then f prime is decreasing. The first derivative is decreasing. Since it's convex, second derivative, the sign of second derivative is negative. So the relation between those three is very important. There are many questions involving this relation. First question, exercise 5. The graph below is graph of the function f. So this is the original function. So the first part of the question is asking about the values that makes x, the first derivative 0, positive, negative. So we will be using first derivative test here. We make a table of variations. Okay, we are looking for signs of f. So this is the original function. Original function is increasing from left to right. From negative infinity till negative 2, function is increasing. From negative 2 to 2, function is decreasing. From 2 to infinity, function is again increasing. So if function is increasing, first derivative is positive, decreasing negative, increasing positive. So this is the table we need to make in order to figure out the sign of first derivative. So f prime of x is 0 at negative 2 and 2, positive between negative infinity to negative 2, and 2 to infinity, and negative between negative 2 and 2. So by just making a table, we can figure out the first part of the question. Okay, second part, for which value of x is f of x minimum or maximum? So we apply the same graph as same table. Function is increasing at first and then decreasing. I see a maximum point here, decreasing at first and then increasing. There is a minimum point. So maximum at negative 2, minimum at 2 then. Okay. Third part. For which values of x is f double prime 0, positive, negative? So since it's about signs of second derivative, we will be using second derivative test. So make a table. This time we will be talking about concavity. So at which value the function changes its concavity? At 0, the curvature changes from negative infinity to positive infinity, second derivative, original function. So from negative infinity to 0, function is opening down, convex. From 0 to infinity, function opens up, concave. If function is convex, the second derivative sign is negative, concave, positive. So we can say, since curvature changes at 0, 0 is point of inflection. This is where f double prime is 0. And it's positive from 0 to infinity and negative from negative infinity to 0. Right? Let's take a look at the part D. On what interval is f prime an increasing decreasing function? So this is the last relation I just mentioned, this one. If f prime is increasing, then we have concave part. If f prime is decreasing, then function is convex. So this graph, this is the table that we need to make. So we just use the previous one, from negative infinity to positive infinity, f prime, and I know that from negative infinity to 0 it's convex, from 0 to infinity concave. So convex means the first derivative is decreasing, concave means f prime is increasing. So on which interval f prime is increasing? 0 to infinity. On which interval it's decreasing? From negative infinity to 0. Okay, and finally, for which value of x the f prime is minimum? So the last table shows us the minimum point for f prime. F prime is decreasing at first and then increasing. So here I have a minimum point at 0. I don't have maximum, I have minimum point. Okay. Do I have an no, this is the last one. I am done answering this question. Right. Okay, let's continue with a ministry exam question. 2024 first attempt. The graph below shows the curve of the function f. This is the original function f. Which of the following is graph of f prime? Okay, this is pretty simple question. If you make the table, it's very easy. So let me make the table first. This is just a question that we solved, right? The same graph, exactly the same graph. See? An exercise question came as Wezari question. Okay, let me make the first table. F prime, f, negative infinity. Function is increasing at first until negative 2, and then decreasing until 2, and increasing again. So f prime is here positive, here negative, here positive. So we can say the graph of f prime is above x-axis between negative infinity to negative 2. Until negative 2 it's above, here until negative 1 it's above, so false. Until negative 2 it's above, yes. Between negative 2 and 2 it's below x-axis, yes. After 2 it's above, yes. B matches. C, until negative 3 it's above x-axis, false. Here until it's always above, it's false. So it seems like the correct answer is B. Okay, by just using a table, one of the tables, I answered the question, I got B. What if instead of making the first table, I made the second table? What would the answer be? let's make a table about concavity, curvature. Here we have convex, concave interval, f prime is, then decreasing and increasing. So we would be looking for a derivative graph who's decreasing at first and increasing. They are all decreasing first and increasing. So by using the second table, I wouldn't find my answer. So in either case, I need to do the first table. Okay, so first for some questions, only the first table is enough. For some questions, both of the tables should be made to find the correct answer. So we have to do the tables. Another exercise question. This time f prime is given. Yeah, this one is given. Now we are gonna do the opposite. In the first two questions, the original function was given f. We were looking for f prime. By making the table, we got it. What if f prime is given? How can you find the information that's asked in the previous question one by one? We had 1, 2, 3, 4, 5 questions. Let's answer the same questions for by knowing the derivative graph. See what happens first. We are asked to find increasing, decreasing intervals, convex, concave intervals, critical values, inflection point, and local extrema. Everything we need to know, we need to find everything. So let's start with increasing, decreasing intervals. So to find increasing and decreasing intervals, we need to make the first table. The relation between sines of f prime and increasing, decreasing of function. So f prime, until negative 2, f prime is above x-axis, so positive. Between negative 2 and 2, the f prime is below x-axis, so negative. After 2, f prime is above x-axis, so positive. So f is increasing in the first interval and then decreasing and then increasing. So the answer to the first question, the critical values are negative 2 and 2. And increasing intervals are from negative infinity to negative 2 union 2 to infinity, and decreasing interval is between negative 2 and 2. So we answered the first part. Now let's answer the second part. The second part was about concavity. In order to figure out the concavity, we should make the second table. I find easier making table f prime and f. So f prime is decreasing at first. Let's take a look at this part. F prime is decreasing at first from negative infinity till 0, and then it's increasing to positive infinity. Decreasing at first and then increasing. If the f prime is decreasing, then function is convex. Increasing, then function is concave. So we can say, since curvature changes at 0, 0 is point of inflection. There's point of inflection at 0. And convex interval is from negative infinity to 0. Concave interval is from 0 to infinity. Okay, we answered the second part of the question. In the first part, we didn't talk about minimum maximum values. So since it's increasing at first and then decreasing, there is maximum at negative 2, decreasing and then increasing, there is minimum at 2. We can also talk about minimum points for f prime. What else do I need to find? I think I am done. I found everything related to this graph. Okay, let's solve a similar ministry exam question. 2022 second attempt. F prime is given. We're asked to find f. Since f prime is a quadratic function, a negative quadratic function, the original function should be negative cubic function, right? It's negative quadratic, then f should be negative cubic. So not b, not d. You can immediately rule out b and d. They are linears. They cannot be our original graph. So option A, this is a positive cubic function. Option C, it is negative cubic function. So that's what I am looking for, a negative cubic function. My answer is C. Okay, this is pretty simple. What if there were two options with negative cubic function? How would you solve the question? We would make a table as usual. Let's suppose we had two similar options. I would make a table if I did. So f prime is increasing from negative infinity to 0. From 0 to infinity, f prime is decreasing. So I can talk about concavity. If f prime is increasing, function is concave, decreasing function is convex. Option C is concave at first and then convex. So this is the only option with this situation. And if I had a similar graph in another option, I would make the second graph, the second table. Let's suppose this didn't help us to find the answer. I would make the second table. So f prime is negative until negative 2, between negative 2 and 2 positive, after 2 negative. We can use the signs of f prime. F prime is negative until negative 2. It's below x-axis. Between negative 2 and 2 above x-axis positive. After 2, it's below x-axis negative. So f would be decreasing at first and then increasing and then decreasing. So function is decreasing from negative infinity to negative 2, increasing from negative 2 to 2, and decreasing after 2. So the first table also help us to find the answer. Okay, if I didn't have I couldn't eliminate all of the options by just using that idea. I would make the tables one by one if necessary. Okay. Okay, there is another question in the book, Partial Test 7, and the same question came in Wazari. We are asked to complete the table by using the signs plus, minus, 0. Okay, let's take a look at each number. For x equals negative 2. At negative 2, it's the sign of f. It is 2, which is positive. At 0, it is 0. It doesn't have a sign. At 3, it is 2, which is positive. At negative 3, it's down here like negative 1, so negative. At 4, it's way up here, so positive. So I determined the sign of f of x. What about signs of f prime? F prime is about slope. At negative 2, what is the slope? At negative 2, the slope of tangent line is horizontal, so it is 0 then. At 0, slope of tangent line is horizontal, so it's also 0. At 3, the tangent line is horizontal, also 0. At negative 3, I'm here. When I go down, I hit this point. At this point, let's draw a tangent line. The tangent line is, I cannot draw it. Sorry, I cannot draw it, but you can see that at this point, the tangent line will increase. Since it's increasing, its slope is positive. And finally, at 4, here we have, so when you draw a tangent line, the line is increasing from left to right, whose slope is positive. Okay. What about f double prime? So what am I looking for f double prime? I'm looking for concavity. So if the region is convex, we will say the sign is negative, concave, sign is positive. At -2, we have a convex region, so second derivative sign is negative. At 0, it's opening up, it's concave, so positive. At 3, it's neither opening up nor opening down, it's point of inflection, so 0. At -3, it's opening down, convex, so negative. At 4, it's opening up, concave, so the sign is positive. So by just using the idea of f prime being slope, f double prime being concavity, we can solve this question just like that ministry exam question. Okay, another question. State the signs of f prime and f double prime on the interval 0 to 2 for each graph. So for the first graph, what is f doing? F is decreasing, right? If f is decreasing, what can we say about sign of f prime? Then it is negative. So what can we say about sign of f double prime? It is decreasing and it's concave in the same time. Since it's concave, then the sign is positive, we can say. So we should be able to know the relation between them. We should know the first table, second table, and the relation between them. This is pretty important for solving most of the questions. Second graph, function is increasing. If function is increasing, then the first derivative is positive. Since the function is concave, then second derivative is also positive. Okay. Third graph, function is increasing. Since function is increasing, first derivative is positive. Since function is convex, then second derivative is negative. The last graph, function is decreasing. When function is decreasing, first derivative is negative. Since function is convex, then second derivative is also negative. It is pretty easy when you know the relation between them. Okay, let's take a look at an exercise question 18 and 19, and there are many ministry questions by using the same idea. F is a function whose derivative is an increasing function. Sketch a graph for f. For f prime is negative, f prime is positive, one by one. So, first, what kind of function we have? First of all, we know that the derivative f prime is increasing. If f prime is increasing, then what do we know about concavity? We know that it's a concave function. So we are looking for a concave function. In this function, we know that first derivative is negative. What does f prime negative means? F prime negative means the original function is decreasing. So we are looking for a concave graph at the same time decreasing concave graph. So in this concave graph, we are not going to take the whole part, we will just take the decreasing part. So just the decreasing part of the concave graph. So this is an example to this situation. The second situation, f prime is increasing, then we know that function is concave. This is the first relation we need to know. We are looking for a concave function. And we also know that the sign of f prime is positive. If f prime is positive, what is your function doing? Your function is increasing. So we are looking for a concave graph whose part is increasing. So we just take this part, just the increasing part, not the whole concave part, just this part. So this is the example to this situation. Okay, same idea, opposite information. Derivative is decreasing this time. If f prime is decreasing, then function is convex. So we are looking for a convex graph like that. But which part are we looking for? So it is different for each question. The first question, f prime is negative. If f prime is negative, then f should be decreasing. So on this concave graph, we are just looking for the decreasing part, this part, something like that, which is given in this question. Second one, f prime is positive. When f prime is positive, what is the function doing? Function is increasing. So on this concave function, we are just looking at increasing part, this part, just like that graph. Okay, so there are similar ministry exam questions. You'll find the answer in options. And one last question, I'll finish the video. Which of the following is true for the graph of f? f of 1 is 0. F of 1 is equal to negative 1, not 0. Negative 1 true, negative 1 true, negative 1 true. Second information, f prime of 0 and f double prime of 1. What is f prime of 0? F prime of 0, the point is here. F prime is about slope. What is the slope doing? Slope is increasing, so the sign of the slope is positive since it's increasing. F prime of 0 is positive. What about f double prime of 1? It's about concavity. At 1, concavity doesn't change. Its point of inflection is 0. So positive being less than 0 is false here. Positive is greater than 0. True. Greater than 0. Yes. Yes. So I eliminated the first option already. So it is either C or D. Now let's take a look at the last relation. F double prime is less than 0 when x is bigger than 1. Let's make a table. F double prime of x is less than 0 when x is less than 1. When x is less than 1, it is convex. Convex. Bigger than 1, concave, sorry, the opposite. Less than 1, convex. Convex means f prime is negative, not positive. Concave means it is positive, not negative. So C is also false. D is the correct answer then. For x values bigger than 1, the graph is concave, which means second derivative is positive. When x values less than 1, on the left side of 1, we have a convex graph. So the second derivative sign is supposed to be negative. So D is the correct answer. So we solved every type of question involving second derivative test, all kind of relations.